This is the fourth mini lecture for section 3.1 of the textbook. We're moving on to our fourth numeration system, which is the Mayan system. This is the system that was used in pre-Columbian Mexico by the Mayan people. The Mayan system, sorry, this is a typo. The Mayan numeration system is another positional system. It's based mostly on powers of 20. So just as the Babylonian system was based on 60, this one is based mostly on 20. There's an exception to that, which we'll see. So the numbers 0 through 19 would be written as follows. There were three symbols that they would use. The first is their 0 symbol, and they appear to have had a concept of 0 as an actual number. And this is how they represented that. Okay, then they use dots and bars to represent 1s and 5s respectively. So, for instance, if I wanted to represent 3, that would be 3 dots. Or 2 dots in a bar. That's 2 1s and a 5, so that would be 7. Or let's say 3 dots and 2 bars. That would be 13. Let's say 1 dot and 3 bars. That would be 16. And then the largest number that they could represent using just these symbols without place value would be 19. 3 bars and 4 dots. Okay, so they went up to 19 with these dots and bars and then also the 0 symbol. Okay, beyond that point, they made use of place value. So they would write numbers 20 and above vertically. Okay, instead of writing things horizontally, as all of the systems we've talked about so far, they would write their numbers vertically. So you'd have the 1s place at the bottom, and right above that you'd have the 20s place. And then the next place is 18 times 20, which is 360. And then you'd have 18 times 20 squared is 7,200. 18 times 20 cubed is 144,000, and so on. So basically it's powers of 20. You're just multiplying by 20 at each stage, except right here, instead of a 20, it's an 18. Now, why did they introduce an 18? Why didn't they just stick with 20s? They actually had a system that was purely 20s, but this was what they usually used. And the reason they probably did that is because 18 times 20, 360, that's close to being the number of days in a year. The Mayans were fairly sophisticated astronomers. They knew the length of a year pretty exactly. They knew it was a bit more than 360. So, what they might typically have done is number the days of the year from all the way up to 360, and then they would have what's called an intercalary period. So a little space of 5 or 6 days that's not actually numbered. They would have a religious festival at that time or something like that. So they had this 18 here probably because they were using this system for their calendar. Okay, so let's take a Mayan numeral and try to represent that in modern notation. We'll start with something, let's say 3 places. So let's say 3 dots in a bar. And then this guy. and at the bottom, say a dot and 3 bars. Well, let's make it 3 dots and 3 bars. No, sorry, 4 dots. Okay, I want to make it a little bit varied. All right, so at the top, well, we'll start at the bottom. Okay, this is the ones place. That's 19, so 19 ones. And then we've got the 20s place, but there's a 0 in there, so it's 0 20s. And then at the top, that's an 8. But this is in the 18 times 20s place, or 360s place. And so we just add those up. 8 times 360 plus 19. That comes out to 2,899. Okay, now let's go the other direction. Let's try to write the number 3,977 in Mayan notation. So again, I'm going to have a ones place at the bottom, 20s, 360s, 7200s, and so on. And I start with the largest place value that will divide into my number, and that would be 360. So I divide 360 into here. Oops. So I get 11 360s. Okay, I don't have any 20s, so kind of like the last one. And then we have 17 ones. So I need an 11 on top. And then the 0. And then a 17. Okay, this one we happen not to have any 20s. If I had a problem where this remainder was larger than 20, then the next step would be dividing 20 into that. And then that number would be the 20s place, and then that remainder would be the ones place. So that's the Mayan system. That was the fourth system we had to talk about. The fifth system is called the Indo-Arabic system. And this is the one that's familiar to you because it's the one that we use in our culture. Okay, it's called the Indo-Arabic system because it was invented in India. No one knows exactly when, but maybe 2,000 years ago, give or take. It took a long time to develop there. So invented in India, it spread through the Middle East, and North Africa is transmitted by Muslim cultures. And it entered Europe and Spain. It entered Europe through Spain and Italy during the Middle Ages. There was a big interchange of culture at that time. People were traveling around more than they had in the past. And there was a man who lived around the year 1200 named Leonardo of Pisa. He's from the town where the Leaning Tower of Pisa is in Italy. So Leonardo spent some time in North Africa where his father was working in state business. And while he was in North Africa, he got to know this base 10 system, this Indo-Arabic system, which was not used in Europe then. It was not really known. He took it back to Europe, thought it would be really helpful, and so he wrote a book about it called the Liber Abaci. It's published about the year 1200, and that helped to popularize the system. There's a lot of resistance to it because everything was built up using the Roman numerals. It was inconvenient to change to a different system. So it took a long time to catch on. There's another person, a pope, I believe, one of the Pope Sylvesters, who was from Spain originally, and he had gotten to know this system in Spain, which was ruled by the Moors at the time. And when he was Pope, he also tried to popularize it. And it took some time, but eventually everyone in Europe started using it, and it's what we use today. It's what most people around the world use today. So the Indo-Arabic system is a decimal positional system. That word decimal doesn't refer to, point, blah, blah, blah. It refers to being base 10. It's based on powers of 10. Like think of the Spanish word diez, which means 10. That word des just means 10. And when we talk about the decimal system, we're talking about the base 10 system. Those words mean the same thing. Okay, it uses 10 digits, 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. It's the fact that it's based on tens is probably due to the fact that we have 10 fingers. There's nothing special about the number 10, and you could use the same idea to use any other base. And we'll talk about that a little bit in the next section. So there's nothing special about 10. It's just convenient to us. The numbers 10 and beyond are written with each successive place worth a successive power of 10. So for example, I could write something like 4, 5, 9, 3. That's 4 times. Let me just write out the word 10. 10 cubed plus 5 times 10 squared plus 9 times 10 plus 3. Okay, so when we see these 4 digits in that order, this is how we interpret that. Okay, when we write the number out like that, that's called expanded notation. But again, we're interpreting these digits a certain way. And it's because we're using a decimal system, a base 10 system. That word digit means two things. A digit could be one of these symbols, but the word digit could also mean your finger. And we use our fingers to count, and that's where this system comes from. But again, there's nothing special about 10, and we'll see why that is in the next section. So a numeral is a way of writing a number. Okay, the number is the thing itself. The numeral is the way of writing it. Okay, for instance, there are many different ways of writing the number 1000. You could have a lotus. That's the Egyptian way. Lotus flower. Let's see, the Roman way. You'd just write the letter M. Okay, the Babylonian way. Well, we have to think about that a little bit. How many 60s go into 1000? Let's see, 1000 divided by 60 is 16, with 40 left over. So you have 16 60s. And then 40 ones. Then we have the Mayan system. There's 2 360s. So we need a 2 at the top. And then there's 14 20s. then there's 0 ones once we do that. And of course, in the base 10 system, or the decimal system, we have 1, 0, 0, 0. Okay, those are 5 different ways of representing the same number. Okay, they are 5 different numerals. Okay, the number 1000 is the same in each case. So that's a really important thing to understand. Numerals are different from numbers. A numeral is a way of writing down a number, but the number itself is the same. It doesn't matter how you write it down. 10 times 10 times 10 is 1000, no matter how you choose to write that down. Okay, as a teacher, you will be teaching your student how to use the base 10 system, but you'll also be teaching them about mathematics. Okay, they're not the same thing. When you teach your students addition, part of that is teaching them how to add in columns in the base 10 system. But more important than that is teaching them what addition is, what it accomplishes, how we think about it. And those are 2 different things. Just because someone knows the process for adding numbers and columns does not mean that they understand what addition is. And as a teacher, you teach both. So teaching students how to add 3-digit numbers in the base 10 system is different from teaching them what addition is and what its form. Both need to be taught, but the second is by far the most important of the 2. Okay, and your exercises for this section are numbers 1 through 19. That's section 3.1 in the text.